time, space, and the size of the universe when we look out into space. We're not just seeing things that are far away, we're looking into the past. For example, the Sun is about 93 million miles from Earth, and it takes light about 8 minutes to travel that distance. So when you look at the Sun during breakfast, you're actually seeing it as it was 8 minutes ago, not as it is now. This connection between time and space becomes especially important when we talk about very distant objects in the universe. In astronomy, we use a measurement called a light year, the distance light travels in 1 year. 1 light year equals about 9.5 trillion kilometers, or nearly 6 trillion miles. Since nothing travels faster than light, using light years makes sense when talking about cosmic distances. Astronomers have determined that the universe is 13.7 billion years old. So a natural question is, how big is the visible universe? At first glance, the answer seems easy. If the universe began 13.7 billion years ago, then the farthest light we can see must have traveled 13.7 billion light years. That would suggest the visible universe is a sphere with a radius of 13.7 billion light years around us. But that answer is completely wrong. Why that simple answer doesn't work? The universe is expanding, and it has been since the Big Bang. In fact, the early expansion was even faster than it is today. This means distances between galaxies have changed dramatically over time. Just after the Big Bang, the universe was filled with light. Some of that light has been traveling ever since and is now reaching Earth. This light is called the cosmic microwave background radiation, CMB, the oldest light we can detect. It comes from every direction, and it's like a photograph of the universe's birth. Now, you might think this means the visible universe is a sphere 13.7 billion light years in radius. But there's a catch. Space itself has been stretching during that time. That light may have started only 42 million light years away when it was emitted, but as space expanded, the point from which it came moved farther and farther away. If we account for that expansion, the spot that emitted the CMB radiation is now about 46 billion light years away. The role of dark energy around 5 billion years ago, something called dark energy began to dominate the universe. Dark energy causes the expansion of the universe to speed up instead of slow down. Because of this acceleration, the light from the early universe had even farther to travel to reach us. So, instead of being 13.7 billion light years away, the edge of the visible universe is now 46 billion light years away. This gets confusing. We're seeing light that was emitted shortly after the Big Bang from places that were relatively close, but which have since moved extremely far away due to expansion. We see those areas as they were, not as they are. Back then, those regions looked just like Earth did, a hot soup of particles. But over billions of years, they evolved into galaxies and stars too. We just can't see them in their current form because the light from now hasn't reached us, and never will. Some galaxies will be lost forever today. There's a sphere around Earth with a radius of 15 billion light years. Objects outside of that sphere, right now, are so far that their current light will never reach us, ever. Even if we wait forever, we'll never see them as they are now. Even stranger, we are losing visibility of stars all the time. Around 20,000 stars per second are slipping out of our view due to the expansion of space. We may see the light they emitted earlier, but we'll never see the light they emit from now on. One day, because of this continuous expansion, almost all of the galaxies we can see in telescopes today will disappear from view. Eventually, only the galaxies in our local group, like the Milky Way and Andromeda, will remain visible. The big picture, so what's the real answer? The visible universe has a radius of about 46 billion light years. The universe itself is only 13.7 billion years old, and due to expansion, we're seeing faraway objects as they were, not as they are. And the most important takeaway, if humanity ever wants to explore distant galaxies, we should start soon, before they're lost beyond reach.